So here is our last problem, a hexagonal prism. Okay, now we're given very little information about this, and this is part of sort of the convention of assumptions that is made. If you're only told one dimension of the hexagon, it means that you couldn't possibly figure out what all these sides are actually equal to unless it was a regular hexagon. So a lot of times in these problems, if we're not told very much information, it is implied that we need to assume that in this case, the two bases, the hexagon on the top and the hexagon on the bottom, are regular polygons. So if there's not enough information to otherwise figure out what the areas would be, you need to then assume, okay, they're talking about regular polygons. Now I know this is tough. In other words, like, well, gee, in this case, problem we just finished, this wasn't a regular triangle. It wasn't an equilateral triangle. Actually, it was an isosceles triangle. But we kind of got that because, well, we were only given one side, and then we were given a perpendicular, which was enough information for us to realize that this side could not possibly be 14, right? Because if it were, how could the height be taller than one of the sides? It can't be. So, especially when you have a right triangle, the hypotenuse has to be larger than this, but this clearly can't be 14, right? So, therefore, you've got to look at the information that you're given and then decide what appears to be the assumptions. That takes some getting used to. And we're doing this rather fast, so just take my word for it that this is a regular hexagon. Now, let's draw the hexagon out. Before we actually get to the solid itself, let's just draw a hexagon. And according to the picture we've got, the radius of the hexagon is 4. We've got to figure out what the sides of the hexagon is just based on that radius. Well, again, some of our assumptions kick in. First of all, if it's a regular hexagon, then the angle degree of each angle is going to be 360 times n minus 2 over n.